I'm doing these questions for me to expose you to what you should expect in the near future. Okay? So you can read all the stories there, but the most important thing when you see the question is, I told that whenever you see a diameter, a radius, a chord, a center, that's very important. Now we did also the cyclic parts, so you must look at 4 points on the circumference. If they are there, then it's most likely that you have to use one of the cyclic part theories, right? So that's how it is. We have got a center given there, right? So the first question says, determine stating reason the size of S, angle S is this angle there. Okay? Now finding angle S is very easy because SR is a diameter and angle P is subtended by the diameter. That's theorem 3. Okay? So it will be angle in a semicircle. So, but before you do, you find S, you need to know that this angle is 90 degrees. But the way you lay it out is very important. So you start by writing down why angle P is equal to 90 degrees. So we say angle P is equal to 90 degrees. So this is angle in a semicircle. That's where you should start. Okay? Then we identify a triangle because angle S is in a triangle. So I need to identify the triangle. So it will be in triangle PSR. Okay? In that triangle, if I add angle P plus angle S plus angle R2, I'll get 180 degrees. Alright? So I have to write my reason here, sum of angles in a triangle. Okay? So angle P is 90 plus angle S, that's unknown, and angle R2, that's 30 degrees. So my angle S is going to be 180 degrees minus 120, and that will give me 60 degrees. Alright? And then we are done. Any question? Right, then R1. Need to find the size of this angle. Okay? Now, to find the size of that angle, okay, I'm not sure how you approached it, but how to do it this way. Okay? It's possible that there might be more than one way, but first, since I know the value of angle S is equal to angle N or N1 plus N2, because they are angles in the same segment, then I'll identify a triangle which will be TNR. Then use TNR to get R1. Then I'm done. Okay? That's how I would approach it. I don't know if there's anyone who is seeing something else, but that's how I would approach the question. Okay? So let me do that on the next page. Okay, I'll do it here. Alright, so first thing, I'm going to say angle S is equal to angle N. Okay? And they are both equal to 60 degrees. And my reason, angles in the same segment. That's theorem 4. Right?
What would happen if you gave the reason against just yes?
The page that I gave you, that was the check that. You get a 0 for that. Okay? Alright. So once I have that, then the next thing is I'll need to identify a triangle. So it will be in triangle TNR. Okay, in triangle TNR, fortunately it's indicated that angle T1 is 90 degrees. Okay, based on theorem 1, right? Well, just allow me to write the reason why T1 is 90. Okay, so I'll say T1 is equal to 90 degrees. That's line from center, perpendicular to chord. I need to remind you that at this stage we have done up to theorem 6 together with the corollaries of theorem 4, right? You are expected to know and to apply all the geometry theorems up to this point. Some of the questions you need to incorporate all the theorems, all right? So T1 equal to 90, line from center, perpendicular to chord. I'm just writing that, well, because you never know, maybe if it's in a test or an examination, maybe the examiner can allocate a mark for knowing why T1 is 90. Okay, that's why I'm writing it down. So that I can be on the safe side if I was writing a test or examination. So the next thing now is to say T1 plus angle N plus angle R1 is equal to 180 degrees. And the reason sum of angles in a triangle. Alright? Then my T1 is 90. My angle N is equal to 60 degrees plus R1. That will give me 180. So R1 is equal to 180 minus 150. So you get 30 degrees. Okay? I want you to be aware that it won't be that easy to get all 3 marks without providing as much information as possible in terms of statements and reasons.
So is Q1 not equal to R1?
Yes, it's also equal to R1.
So what is the angle?
So this angle here is equal to that angle. But do you know the size of P1? You can find it out.
Is it not from
Okay. I'm saying at this stage, do you know it? Which means you have to find the value of P1. Okay. Yes.
We were finding angle X, the previous question.
Yes.
But I did it also found X. I double checked the answer right. I told you the P1.
Okay. Yeah, it's fine. It's okay. Okay. Remember, I think I told you this. Maybe I didn't. I need you to be aware that when you're answering geometry questions, answer them based on what you are seeing. Okay? Because we are different individuals. Mr. Chukwanda, this is the way that he saw it. And it is mathematically correct. You might have seen it the way that you are saying that, okay, after finding angle S, you should state why angle T3 is equal to 90 degrees. I hope you wrote that down. You have to write that down. Why T3 is 90, the vertical opposite to T1, and you must know why T3 is also equal to 90 degrees. Right? Then use sum of angles in a triangle to get P1. Then you say P1 is equal to R1. That's fine. And that's correct as well.
That's the reason. That's the reason.
What?
So P1, so if you have to find it.
Okay, if P1, if you say P1 is equal to R1, it's because of angles in the same circle.
Yeah, so but if you have to find P1,
In sum of angles in a triangle, you add S and T3, subtract from 180, then you get P1. Are you following that? Now, in a memo, both solutions must be provided. The one that I gave you and the one that some of you probably used to find P1. Both must be there because we don't see the diagram the same. Yes?
you need to state like all the radii that's whole and so.
Okay, I don't see the reason why you should state whether NO is a radii and OR is a radii. For this question, I don't think it is necessary for that. It is only necessary if you are going to use that. If you are going to use it, then you can state it. Sorry? Angle what? Angle N is equal to 60 degrees. It's a good question, at least you are asking. Right? Remember we found angle S is 60 degrees. Angle N and angle S are both subtended by the same chord PR. Therefore, they are angles in the same segment, hence they are equal.
What if you can just see what the angle is?
What?
What if you can just see what the angle is?
What do you mean by that?
I can see
Okay, you must tell us why you are saying that R1 is 30.
sometimes
You can't.
No, I'm saying in this scenario you can see it.
You can see the how.
It's
Okay, listen.
a 60 by 50 times.
Okay, how are you saying that it's 30? Tell us why you're saying it's 30.
I just do it.
You see, okay, let me make this very clear. Geometry is not about the hands, it's about how you get to it. Why are you saying that angle R1 is equal to 30? Tell us.
It's a 60 by 50 times.
That is right, so because you can see that the same number is 30 here.
It's a 60 by 50.
Well, don't make an assumption. Show us.
It's not until
Alright, okay, let me carry on. Right. Use the theorems and the geometry concepts to tell us why R1 is 30. Yes?
I would like to ask, because earlier you said Q1 and R1 are angles in same segment. Which chord, or is it the diameter that's subtending?
Right. Thank you. Okay, thank you very much for asking that. P1 is equal to R1. Now, yesterday, I remember one of you, I think it was Zach who asked about the chord. Remember, I told you that sometimes the chord may not be drawn. Remember that? So we can construct a chord here. Sn. That Sn, because point S and point N are on the circumference, you can draw a chord. But the chord is not visible. But you need to be aware that it exists. Or we can say arc Sn subtends angle P1 and angle R1.
So,
Yes?
so in the case we allow to just can we quickly do the last one?
Okay, listen. As you do geometry, when it comes to circle geometry, you are going to realize that it's not always that the chord is drawn like in the case of PR. But as long as there is a point on the circumference and another point on the circumference, it means there is a chord, but it's an invisible chord. If we don't want to explain in terms of the chord, we explain in terms of the arc.
No, so I mean, like, you know, in the circle, let's say you have a line, let's say you have a line, but you add your own line, so make a side what?
Okay. Generally, when you are dealing with triangles, it's not encouraged for you to construct your own triangle. You use the given triangle. But when you are dealing with chords, there are two scenarios. Either the chord can be drawn, which means it will be visible, or it may not be what? Visible. Like in the case of chord Sn. It's not drawn, but you should see that, okay, I have a point at S and I have a point at N, therefore there is a chord which exists.
So, you just explain the game, what the subtend is.
Alright. Let's calculate N1. Now, to calculate N1, right, I'm not sure how some of you approached it, but I hope you are aware that we know the size of R1, right? And I know the size of this angle here. Now, finding N1, there's more than one way of doing it. Okay, there's more than one way of doing it. But I'm going to use triangle TNR. Okay, but if I try to use triangle TNR, I need to know what is the size of N2. Okay, I need to know what is N2. So I'm going to find N2. N2 is equal to R1 because OR is equal to ON. They are both radii at the circle. So N2 is equal to R1 because they are angles opposite equal sides. So if I find N2, I'm almost there. Okay? So I'm going to find what? N2. Okay, so for 8.1.3, for 8.1.3,
It's not going to show you.
can you allow me to finish? Then I'll give you an opportunity to tell us how you will do the question. There's no problem. So 8.1.3, right? I need to find N1, remember. So I'm going to find N2. That's how I'm seeing it. Okay? Remember, I'm not doing the question using a memo. That's how I'm seeing it. So I'll find N1. But before I do that, I'm going to say ON is equal to OR. So ON is equal to OR. In my reason there, they are radii. Right? Then I'll say therefore N2 is equal to R1. So both are equal to 30 degrees. And that's angles opposite equal side. Okay? Now once I get the size of N2, I already know that T1 is equal to 90 degrees. So if I add T1 and N1 plus N2 plus that N, okay, this one is R1. That's one way of doing it. But the shorter way would be, I know the size of the whole angle N1 plus N2. So I'm going to use that. Okay? N1 plus N2 is equal to 60 degrees. Okay? So I'll say N1 plus N2 is equal to 60 degrees. I don't need to write the reason for this because I proved before that angle N is 60 degrees. Okay? Therefore, my N1 is going to be equal to 60 degrees minus 30 degrees, and you get 30 degrees. Okay, now I want you to be aware that for 8.1.3, there is more than one way of doing the question. So I've told you two. I decided to take the route which is shorter, right? I could have used triangle TNR, okay? But I decided to just use this angle here. So can you tell us how we did?
So first of all, I said that O1 is equal to 2 R1 because of angles at the center is equal to 2 figures of the circumference and the subtend.
Okay, yes, that's correct. What this called here is subtend that angle. It also subtends this angle.
And then I got the O1 equal to 60 degrees. Then I use sum of angles, triangles,
TO. That's correct as well. Anybody else?
So repeat the.
Is there anyone who saw it in another way?
I just saw that.
Right, so that's how we approach it. I need to talk about the last question, quick.
Oh, yeah.
Sorry? Don't worry, it won't take me long. It won't take me long. No, it won't take me long. Alright, this question, can I have your attention? You are supposed to prove, if you are, it says it is further given that NW is not WR, so this length and that length are what? Are equal. What does that mean with regard to this angle? So you got 90. So what you say is, now you have to use the converse of theorem 1. So we say
Attention, please. Can the hockey boys?
W2 is equal to. The reason why this angle is 90 is because of the converse of theorem 1, line from center to midpoint of chord. Now, to prove that TNWO is a cyclic quad, you have to use any one of the three strategies that I told you about. Converse of theorem 4, converse of theorem 5, and the converse of theorem 6. Now, T is this point here. Let me just illustrate it quickly. This question is not so difficult. Actually, it's so easy. T N O W, right? What it means is that I can draw a circle passing through those 4 points. The circle is not drawn. The circle is not drawn, but it can be drawn. Okay? So, how can I tell or to prove that it's a cyclic path? This angle here, I have proved that it's equal to 90 degrees. Okay? The quadrilateral is this one here, which means this angle is an exterior angle of the what? The cyclic path, because this angle here is 90. So I'm using the converse of theorem 6. So I'll say T1 is equal to 90 degrees. This was proved in which question? Let's go back. We proved that. Yeah, that's 8.
T1 is given.
Okay, you can say given if you want, or you can say proved in the previous question I spoke to, or you can say given if you want, right? So I proved that in 8 point what? 1.2, right? Or you can say it's given, either of the two, right?
Okay,
now,
theorem 1 to prove it.
Therefore, W2 is equal to T1, okay? Therefore, Tn WO is a cyclic path. Okay, you must give a reason. The reason, I'm going to write it in using a different part. It will be converse exterior angle of the cyclic path. Okay? It will be converse exterior angle of the cyclic path.